طيب شباب, we let me okay wait, this is what we want to cover in this lecture. As we have said last time, we would like to cover the steady state error. Remember, the typical response of underdamped system is this way, where this area we call transient, and this is steady state. In the transient, we cover certain, parameters that control or the measure of performance in the transient. We talked about the overshoot, percentage overshoot. We talked about the speed of the response. We talked about the settling time. In here, we will be talking about the steady state error. At steady state, our performance objective is to how much steady state error you have, and if you can eliminate this one or minimize the steady state error. Okay, so remember last time we said, in general, you have a system, a feedback system. You have feed forward and feedback loop. And we define the steady state error, E steady state, is the signal, is the difference between the desired output, R, and the actual output. Okay. This is the steady state error. Now, let me put this steady state error, let me put it in terms of the input, function of the input. Can I do that? So E steady state equal to R of S minus, what's Y of S in terms of R of S?
It's the negative feedback
we do
loop.
the negative feedback, one G of S over 1 plus GS.
Exactly. The direct transmission, direct gain over the loop gain. The loop gain, G times H of S. Okay. Which is equal to 1 minus, G of S, 1 plus G of S, H of S, times R of S. Okay, usually we know what is G of S, what's H of S, and suppose I have my input is a step function.
It is 1, yeah.
How do I find the steady state error? So what do I do? Normally, I'll substitute for R, which is, if it's step 1 over S, then do partial fraction, then go to the time domain and find E of t. And you let the steady state, E steady state, equal limit as t goes to infinity of, E of t. Sorry, E steady state E of t. Okay? But this process is a little bit long. Let's use the final value theorem. This is the same as limit as S goes to 0 of S E of S. So rather than find the steady state error by inverting in the time domain, I can do it in the frequency domain.
And S will cancel with R of S.
This is okay. This okay. If no, you are right. If my input is a step, but in general, if my input is a RAM, then one of the S will cancel. Yes. You simplify whatever. Okay. Any question here? There is another error which we call the actuating signal. The actuating signal is the difference between E of A equal to E of A equal R of S minus H of S, Y of S. In the case where we have a unity feedback system, E of S and E of A will be the same. So this is basically what we have said. And this is the steady state error in terms of R of S. Any question here?
دكتور بس الاكشويتنج ايرور هذا والستيدي ستيت ايرور ايش الفرق بينهم يعني؟
الفرق بينهم usually okay when you have the cooling system in the room, what do you have?
اير كونديشننج مثلا.
Air conditioning. So what do? You sense, you have a sensor, you set the input as
25 مثلا.
a certain degree, and then your controller will work such that we hope that Y will be the same as R, isn't it?
تمام.
If Y is different from what you set, from your set point, okay, it will,
after a long time.
then this signal will test and it will give a command to the compressor in here to work again. So the actuating error is the signal which will make your controller start working again. If you reach the desired value, the actuating signal will be 0 and there is nothing there is no signal there, and the compressor will stop working. So the actuating signal is the signal which will go to the controller, activate the controller to make your system, your control system will work.
And in this case, Dr. H of S will play the role of the conversion between, for example, the desired and the output. For example, if the desired, if the R of S is just a voltage.
Look, sometimes, sometimes, Abdurrahman, it could be, suppose you are, okay. Your input usually to a system is a voltage.
Yes.
And suppose you are controlling motor. What's the output of motor?
The theta, or basically the angle and the torque.
Angle, okay, position, theta.
Yes.
Now, how do I compare theta and R? This is position and this is voltage.
So you need a conversion factor.
Exactly. So think about it in this way. You want to convert it. This is tachometer, they call it. It will convert the position into voltage because I want to compare, apple to apple. So you.
واضح دكتور.
Okay. Any other question? Okay, let's move.
دكتور معليش.
تفضل.
الفاينل فاليو ثيرم هي كانت اسم مضروبه في اي اوف اس وهذه سبيشال كيس.
كيف الفاينل فاليو ثيرم؟ الفاينل فاليو ثيرم كده look E steady state equal limit as usual infinity of E of t. This is the same as limit as S goes to 0 S E of S. What's your question?
Oh no, I just forgot that you multiply by S.
You just what?
Forgot that we should multiply by S.
It should be multiplied by S.
Okay, thank you.
Okay. Now, suppose I have, this is my system, a unity feedback system. Okay? And I would like to obtain the error. The error in this case equal the direct transmission, which is 1 over 1 plus G of S. I think many of you in the last quiz, when we asked the transfer function between Y2 and Y1, they never thought about the effect of the loop gain.
Don't remind us, Doctor.
So this is the steady state error. Okay. Now, let us take the steady state, well, then E steady state equal to limit as S goes to 0 of S G of S. And let me study now, let me study the different, okay, first of all, let me see what's the effect.
لحظة. كيف دكتور جي اس؟ في المفترض انها تاخذ التي اس اللي هي الحين ليش الاي اس اس equal limit as s goes to 0 s multiplied by g of s.
Steady state error equal limit as t goes to infinity of e of t, which is equal limit as s goes to 0 s e of s.
تمام بس هنا فوق مكتوب s g of s.
No, this is r of s.
لا قصدي الاحمر.
وين الجي اوف؟ yeah, this is what's wrong? I don't know. I didn't...
لا الريد دكتور الهاند رايتنج اللي فوق.
Oh, no, it should be e of s. Sorry, e of s. This is e of s. Okay. Now, suppose, let me, put g of s in very general structure. Suppose my g of s, okay, suppose g of s is written in this way. That g of s is a constant multiplied by, some zeros in the numerator, some pole at the origin multiplied by poles somewhere else. For example, I have, let's say, g of s equal to k. Let's say I have third order system or second order, s plus z1, s plus z2 over s plus p1, s plus p2. So what is the value of n in my example?
It's 0.
0. If n is 0, I will call this a system of type 0. By the way, what is the order? What's the system order?
Second order system.
Second order. Suppose I add s. I'm adding a pole at the origin. What's n equal to?
1.
So I will call it system of type 1. If I add another integrator, I will call it system of type 2. This will, show us certain simplification in our analysis of the steady state error for the various type of input which we would like to have. Usually, we would like to deal with the step input, ramp input, and parabolic input. Okay? With this in mind, I will be defining 3 types of error constant. In a moment, I will come and show you from where they came. The first one I call the position. Limit as s goes to 0 of g of s, which is equal kp. Then limit of s goes to 0 of s g of s. Okay, I call velocity. I call velocity because, look, this is s and there is no s in here. So there is differentiation. And this is the acceleration. But wait a minute, how do I define it? Suppose I have my input is a step input. Okay, for the same system, for the unity feedback system.
الحين الجي اوف اس هذه الدايركت what is called direct function يعني او الدايركت gain.
This is unity feedback system.
قصدي to generalize it يعني for any system g of s is the direct
in this situation it depends on the system. Okay, we are studying this type of system. Look, if you have more than one, you combine them. This is equivalent. Suppose G1, G2, G3 in cascade, combine them.
Now, if we don't have feedback,
You
طبعا
don't
هذه كلها not applicable لو ما في feedback.
No, wait. If there is no feedback, then open loop system. You are talking about open loop system. So انت وحظك if the يعني يا تصيب يا تخيب يعني.
صحيح. وهذا دكتور لو كان في الفيدباك مثلا في اتش اوف اس.
We'll you deal with it. Look, I will give you an example where you have H of S. It doesn't matter. In here, those constants which we are going to define for a unity feedback system. It doesn't mean that I cannot study the error of the, if I have a general system, which I put at the beginning. Okay, this is the system. You can find this, the steady state error, fine. There is no problem. And I will show you in an example. I will give you later on an example. But now let me talk about this system. So basically, if you have the steady, if you have a unity feedback system, we said the steady state error is going to be limited as s goes to 0 of s r of s 1 plus g of s. Okay. Now, if I am having my input is a step, so this s will cancel the inputs, and I will have only a, which is equal to 1, because I can put the limit inside because it's not a is not function of s, 1 is not function of s, so I put it in this way. And this is basically my kp, which I define in here. Okay, so this kp is associated basically with the step input. Now, suppose for this system, let me look into the various possibility of G. Suppose I have G is of type 0, that's G of S. Suppose G of S equal to K pi, M in here, I equal to 1, S plus ZI over K equal to 1 to Q of S plus PK. Okay? If this is G of S, what will be Kp? Remember, Kp equal to limit as G of S goes to 0 of G of S. What will be Kp? So Kp will be equal to what?
يصير شو اسمه دكتور ضرب الزيروز مع البولز.
Exactly. So it will be K, and it's going to be, let's say, K1.
Big pi.
Okay, constant.
It will be constant, of course.
Now, if Kp is constant, what is a steady state? Will be? What the steady state will be?
Plus 1 A over 1 plus Kp.
Which is, again, another constant.
Constant, yeah.
So, basically, if I have a system, let's say, and suppose this is my step function. So if this is 1, this could be whatever, let's say 0.98. So I'm not reaching my final destination precisely. Okay. Now, suppose I have my system is of type 1. So G of S in this case, okay, and here I have S, and the other thing remain the same. I equal to 1 M S plus ZI over K equal to 1 Q S plus PK. what will be KP in this case? What will be, sorry, okay. What?
Well, it will be infinity.
It will be infinity.
Problematic.
And what is it? No, what's problematic? What?
Zero.
This is perfect.
Steady state error zero.
The error will be zero. That's what you want.
Yes.
Like to eliminate the steady state error.
صحيح.
Okay. Tell me if if S is square, type 2, what will be the error?
Fast, it will be zero and faster to go to zero.
KP is going to be infinity again, and the steady state error will be zero.
Yeah, but it will be faster and it will be better.
Okay.
And
So
the order of convergence will be higher.
Okay.
The order of convergence will be higher.
Will be higher. But there is a compromise. What is the compromise? What will be the compromise?
Like you have many poles, يعني دكتور. The system will be unstable maybe.
Possibly, yes. I'm adding at the origin. I'm adding more poles. I'm adding more poles at the origin. If you add more poles at the origin, your system might go to instability region. So there is a compromise. You cannot, just keep adding poles. That's also not good.
دكتور
Yes.
بالنسبة للكي بي انت اعطيتنا مثال اللي هو مثلا ما حيوصل 1 حيوصل 0.98.
Exactly.
طيب ايش علاقة الكي بي بهذه؟ هل هي تساوي 1 minus 0.98 او
الكي look. The KP is just constant. I'm going to solve an example without using KP at all. Go directly. Look, substitute in here. This is your G of S. Don't even forget about the KP. Just put this one here. If your system of type 0, I'm going to have the error. There will be certain error. KP is just constant being used, okay? But ultimately, what's important to us is the steady state error. So if my system, what we are saying, if my input is step and my system of 0 type, I will not reach the final value unless G of 0, we see, no, not G of 0. No, it will be the transfer function itself should be, 0. So basically, there will be error in the system. I don't know whether I answer your question.
Yes.
Okay.
Yes.
Now, let me have.
Sorry, I have a question كده سريع سؤال سريع. الحين الجي of S we have written الجي of S as multiplication in the numerator zeros, multiplication in the denominator by poles. But it will not make difference if I cannot, for example, break this expression, right?
What do you mean? This is very general.
يعني إذا أنا مثلا عندي S square plus 1 مثلا اللي هو المثال المشهور إنه يكون عندي شو اسمه complex.
Say that again. Yeah, complex, fine.
Complex. هل عادي إني أقول والله خلاص ال B K is minus J and plus J أنا I will go for this or?
Look. What we are saying, G is very general. What's important? How many poles at the origin? That's what that's what's important.
This is what matters يعني.
Exactly. Okay. The other, it is very general. If you have complex, then multiply them. Fine.
ممتاز.
Okay. Fine. ما عندك أي إشكال. This is very general. Okay. Now suppose I have my inputs is a RAM. So we said steady state error equal limit. Again, we are having unity feedback system. Again, we are dealing with the unity G of S. Okay, this is minus RY. And this is the same. Now, R is a RAM. which means that in the S domain is going to be A over S squared. So if this is the case, this is what I'm going to have. And if you put, the limit, this will go to 0, and I will have limit as G of S. Okay, and this is where, remember the second one we call it. This is KV I'm defining. Call it the velocity error constant. The velocity, because this is position, I'm differentiating. Okay, now let's talk about the various, type of G. Let's start with, again, G of S n equal to 0. So G of S equal to K, I equal to 1 ms plus zi over, K equal to 1. This is Q, and this is S plus P K. Now, wait a minute. Abel Khail. Abdullah? Am I pronouncing
Yes,
it
Doctor.
correctly? Okay. Now, Abdullah, what will be in this case if my input is around? What will be KV if n equal to 0? What's KV equal to?
Infinity.
What? KV will be? Why infinity? For this,
It will go to 0. Sorry.
okay, look. If S goes to 0, for the ramp, it's going to be what? Look, substitute S equal to 0, what do you get? You get the multiplication of Zi over PK. So it's going to be constant.
لحظة يا دكتور كيف constant؟ الحين احنا ال KV is limit as S goes to 0 S multiplied by G of S.
Yes. Wait.
في نقطة مهمة كمان.
Yes. Wait. You are right. S G of S. So
في مشكلة كمان يا دكتور.
This is infinite. This is going to be 0. It's going to be 0. Isn't it?
إيه بس في مشكلة يا دكتور. الحين ال M وال Q are they equivalent? Are they the same?
Not necessarily.
لأنه لو في واحد منهم لو ال Q مثلا is higher ممتاز. In this case it will not be شو اسمه. It will not.
ليش you have S in the numerator. You have, okay, let's take example. S times, let's say 3, S plus 5 over S plus 6, S plus 7. Limit S goes to 0. Equal to what?
We will multiply them.
Yeah, this ممتاز. الحين يا دكتور هذه 0. حط الحين في الدينومينيتور مثلا S plus 4 زيادة في الدينومينيتور.
Here.
ايوه.
طيب.
بتصير 1 ما هي 0.
ليش؟
يصير في عندي اس كيوب فوق واس كيوب تحت. هذه مو انفينيتي صح. 0 another 0 big 0. but لو كانت يا دكتور يعني ما تفرق.
لا عبد الرحمن. No, listen, don't No, this is clear. I have S multiplied by this one. This S goes to 0. So no matter what you have, it will be 0. Okay? So now, thank you, Abel Khail. Shukran. Okay, so what will be the steady state error?
Infinity.
Steady state equal to infinity.
يعني السيستم unstable يا دكتور ولا كيف؟
Not unstable, no. It is not attacking what you want. It
But
doesn't
the error is infinity. We
you-
don't.
يعني كأنه positive feedback صار.
yeah feedback بس انه يعني either for this type of input is useless.
Useless صحيح.
Now suppose I have n equal to 1. So I will have limit as s goes to 0 of s times s in here, whatever in here I will have.
So we'll have
This will be what? This s will go with this s. And I will have constant. So E steady state equal to constant. Now, if I will have n
constant.
equal to 2.
Yes. دكتور this will help me a lot in design, right?
Yes. Okay. If n equal to 2
will be
to infinity. And what will be the steady state error?
0.
0.
0. Exactly. Let me clear. This is what I mean. If the type is 0 and my input is a RAM, KV will be 0 and the error will be infinity. If the system of type 1, I will have the KV equal to constant and steady state will be constant. If n equal 2 or more, then steady state error will be 0.
So
Yes.
for n is equal to 0, it is bad, right? Error is infinity.
For this input, it is not good for if I have this input, then steady state error will be 0, infinity.
Does that mean that it will never reach steady state? Or?
Exactly. It will diverge. يعني,
I see.
you want your system to go to, let's say 1, but it doesn't reach 1. It will go to 5,000, for example.
In this case, we need to enforce the G of S, or we need, for example, to alter G of S.
This is what I'm saying. And now let's work an example. If you have the parabolic input, it's going to be the same story. This is just repeated. Okay. Suppose I have this system. Find the steady state error for a unit step. This is not a unit feedback. This is general. The question is, what will be the steady state error in this case? Okay. Let's try the steady state error. What's E of S? We said E of S equal to R of S minus Y of S. This is the error.
Right.
But let me express, I would like to express the error in terms of the input.
We can find the T of S.
Which is R of S minus, okay. Let me express Y in terms of R of S. So it's going to be 100 over S plus 4 over 1 plus 100 over S plus 4 times 1 over S plus 1. Do you agree?
Yes.
So E steady state limit as S goes to 0 of S, E of S, which is equal to, okay, S times
1 over S.
minus, okay, 100. Look, simplification could go the way you wanted. I will work in this way, okay. So this is going to be 1 plus 100 S plus 4 1 over S plus 1 times R of S, which is 1 over S. Limit, sorry, in here I have to have limit S goes to 0. So the S in here will cancel this S.
Then you substitute each
Substitute.
S with the 0.
Can you substitute what? Now you substitute for S equal to 0.
Okay.
So
It's 1 minus 25 over 26.
كيف?
It's 1 minus 25 over 26.
Exactly. 26. Which is equal to 26 in here, and I will have what? 1?
Yes, exactly.
Which is about 3%. If you put it in percentage-wise, which is reasonable. Certain error. 3%.
Yes.
Doctor, what is the reasonable range?
What is what?
The reasonable range.
من سامعك.
Unreasonable range for the error. What is it?
Oh, well, it depends. Look, it depends on, it depends on the application. If you are, okay, working in, as we said, you would like to fill a liquid in cans. If there will be an error like this, it's catastrophe, because your liquid is not going to, it will be spilled over. While,
Yes, true.
while if, يعني, you have the elevator in a building, if there is minor, if it is not precisely, you can tolerate. So it depends on the application. What is good is, as engineer, as design engineer, you will decide. Okay, you will decide.
I see. So it depends on the case.
It depends on what you want to do. It depends on your application.
دكتور
Okay, thank you.
Yes.
بالنسبه للستيدي ستيت ايرور الحين لما يكون عندي مثلا complex system الحين this is part of our system, right? Yeah,
Yes.
as you mentioned, for example, in manufacture or company or what have you, the error can accumulate in this. يعني if we're يعني do the calculate the error for the whole system or for the divide the system into certain parts and then they calculate the accumulated error?
Look, when for complex system, you need each one to perform certain job. Suppose you have the assembly line, you are assembling a car, and something went wrong in certain area. You don't, you calculate that particular area. Okay? In any factory, okay, there are many controllers for many stages. For each stage, it has its own.
Oh, so they separate the controllers. Mm-hmm.
Yeah, look, you are implementing locally. You don't want, okay. Definitely, if you don't correct the local error, it will propagate and then it will be a mess up. So you have to be careful with the local. Now let's move. Suppose I have a unit feedback system. Now, find the steady state error for step input, ramp, and parabolic. Now, before we start, what is the system type we have in here?
And zero.
Zero. So what do we expect the error will be?
Well, for the unit step, I think it's and we have to solve it, Dr. Hassan. Constant.
Okay, it's constant. How about ramp?
Infinity?
Yes,
Steady state
infinity.
infinity for definitely
Zero.
parabolic. Infinity. Before we
Oh, infinity also.
should, if our answer is different from this one, we did a mistake. So let's find out. E of S equal limit S goes to 0 of S, E of S, which is equal to, okay, limit S goes to 0 of S times, okay, 1 over 1 plus 1,000 S plus 8 S plus 7 S plus 9 multiplied by R of S. But R of S is 1 over.
انت على طول يعني دكتور من الفورمولا
على طول
مباشرة.
yes على طول ما يحتاج يعني you can do it directly. You don't have to worry about the constant. Which is equal to what? The S will go with the S and you will have what? 1 over 1 plus 8,000 over 63.
Yes.
Whatever that value. Which is going to be?
Very small.
1 over 501, Doctor.
What?
1 over 501.
No, what do you mean 501? 8,000 you said. Oh, yeah, you divide, okay, you divide, yes. Anyway, this is what it's going to be. Okay. In here, I have done it differently. I assume in here, of course, we will be talking about stability later. We are assuming that the system is stable. Now,
We have to assume this, Doctor, right?
If?
We have to assume that the system is stable or ensure the system is stable.
Definitely. Otherwise, it doesn't make sense. I mean,
صح. Otherwise, why we are
we know
this?
that we are not going to reach steady.
Yes.
Never reach steady state. So now, suppose my input is a ramp. What will be this term is going to be?
Will be S square, 1 over S
It's going to be
square.
square. If this is square, this will go. I will have S in here, and I will have S.
0 in the denominator, so infinity in this.
So for the ramp equal to infinity, and how about the parabolic? The parabolic you have S cube.
More infinity. Big infinity.
Again. So it's going to be. So basically, this is as anticipated as we anticipated that for the step input you have a constant, for the ramp it's going to be infinity, and for the parabolic input the steady state error will be infinity. Now let's take one final example.
Type 1 system.
I have this what?
Type 1.
Yes, this system is type 1, and say find K so that there is 10% error in the steady state. Again, let's think before we solve the problem. What will be, okay, this is type 1. What will be steady state if R of S equal to 1 over S? What
0.
0.
0. If the steady state error will be 0, so K could be any value. Isn't it?
But he gives us 10%, so
I don't have to worry about this type of inputs. How about if my input, if R of S equal 1 over S cubed?
So it will be constant.
It will be equal to infinity.
E steady state equal infinity. And no matter what is K, I cannot, correct it. So I left with what input I should have?
The ramp only, the ramp, yes.
The ramp input. So if I have E steady state equal limit S goes to 0 of S E of S, which is equal to limit S goes to 0 of S times 1 over 1 plus, okay, K S plus 5 S plus 6 S plus 7 S plus 8 times the input, which is what is the transform of the input?
Over K over S square.
1 over S square.
1 over S square.
Unit ramp. So S will go with 1, and I will have limit S goes to 0 of 1 over S plus, the other S will go with this one, K S plus 5, S plus 6, S plus 7, and S plus 8, which is equal to, okay, which is equal to, so E steady state equal to 1 over, okay, 5k over 6 times 7 times 8. Is this clear?
Yes.
So I want this one to be 0.1. The steady state error, 10%, so it's 0.1. Or each steady, so basically I will have whatever this multiplication, 6 times 7 times 8, it will be 42 times 8, I think 340 something. No, 336, I think. I'm not sure.
صحيح صحيح
It
صحيح.
will be 67.2.
0.5k, sorry,
Oh, no.
5k equal to 0.1 or k
خلاص.
336 over 0.5, which is going to be
672.
672. So this is the value of k, which will satisfy, okay, which will satisfy my requirements. I choose any value greater than this value, okay? We are going to see, look, by adjusting k, I am eliminating or, you know, reducing the error drastically. But we are going to see later on, you cannot go indefinitely. That you cannot take any value. It's true that 672 will eliminate the error, but it might cause instability. We will discuss it a little bit later. Any question?
Doctor,
Further.
what about the errors that we discussed